The drawing process of the last video was so boring.
It was not that bad.
Actually, you know what? Why spend 10 hours drawing when you can spend 100 hours failing to automate it? So I modeled this character in Blender, and Blender would actually be so ideal if not for the fact that I want real-time motion capture, and the scripting API of Blender is absolutely abysmal.
Have you heard
I'm
of...
sorry, but the stub is not a good solution. So now I have to build my own rendering thingy. I decided to go with Bevy because it is written in Rust. For the motion capture, I went with MediaPipe and Solid.js because the only thing that's worse than web development is mobile development. MediaPipe only gives us key points in the 3D space, and we still want to convert that into rotations in order to move the model.
Is this gonna be another IK video?
I'm too lazy to do that, so instead we're gonna do just FK.
This shit is so ass.
One problem that often comes up when we move from the realm of pure programming to practical application is that the data observed in the real world is often noisy. The Kalman filter is a recursive algorithm that provides an optimal estimate of the state of a linear dynamic system from a series of incomplete and noisy measurements. The basic idea of the Kalman filter is to represent the state of the system and the associated uncertainty as a normal distribution. At each time step, the filter operates in two stages: prediction and update. To illustrate this, consider a car moving along a straight line. We want to keep track of its location, but the position measurement is inherently noisy. In the prediction stage, the filter uses a model of the system to estimate the next state based on the current state and any control input. It also estimates the uncertainty of this prediction because we cannot fully trust our model. When a new measurement arrives, the filter enters the update stage, where it combines the new data with its initial prediction and assigning weights based on the certainty. Mathematically, this balance is controlled by the Kalman GAN, which determines how much of the estimate should be corrected based on the new information. Over time, the Kalman filter continuously refines its estimations. Even if individual measurements are not reliable, the combined result tends to be fairly accurate. Yes, what I wrote on my script. In practice, it still looks pretty ass.
Could it possibly have something to do with your garbage topology and rating?
Did someone say graphics programming?
No?
Bevy is a fine game engine, but the built-in phone reflection model looks quite generic. If we want something more stylized, we will have to write our own shader.
How about you fix the rigging
In the
first?
material shader, we sample the sketch texture based on the quantized color. Then in the post-processing step, we apply this convolution filter on both the normal and the depth map. This secret stylized rendering technique was revealed to us in chapter 15 of the second edition of GPU Jam.
No, I'm pretty sure you got it from somewhere else.
Anyway, here's the result. I also made the mouth out of a billboard to get that hyper-realistic facial expression.
Well, but it still looks much worse than Sora too.
I guess you're right.
They say I achieve. Maybe it's time to get a job.